Okay, as we get into our lesson today that involves a lot of radicals, um, I want to just look at, do we know how to simplify radicals? Well, that was the factoring tree where we looked for doubles, and if there was a double, it went out. We could simplify it. So we've done simplifying radicals. Adding and subtracting radicals, that came into the end of that assignment where you were trying to simplify. You can only add or subtract if you have like terms. Like 3 square roots of 5 minus 2 square roots of 5 will be 1 square root of 5, or just square root of 5. If you had 3 square roots of 5 minus 2 square roots of 3, you cannot subtract those. So you have to have like terms if you are adding. If I would add 3 square roots of 5 plus 2 square roots of 5 would be 5 square roots of 5. But if they were different terms, you couldn't add. So simplifying them to see if they're the same or not. Multiplying radicals. You can multiply anything together. And I think that an example that I had up here a little while ago is square root of 3 times square root of 2 is the square root of 6. Correct. How about square root of 2 times the square root of 6? Square root of 12. Now square root of 12 you can simplify. Because you can do the factoring with 2 and 6, 2 and 3. So instead of leaving it as the square root of 12, we would come up with 2 times the square root of 3. So you can multiply together, but then look to see if you can reduce. Why didn't I think about that on this one? Well, I knew 6 could only be 2 times 3, and you can't, there's no doubles. You can't simplify. What if you had 2 square roots of, or 5 square roots of 2 times the square root of 2? 5 times the square root of 4. What's the square root of 4? 2, just a plain old 2, right? So 5 times 2, this answer is really 10. Some of you are writing down examples to look at. We've got some things that we can do. Multiplying. Dividing radicals by radicals, that's what was on that bell ringer. I think it was something like 4 square roots of 6 divided by the square root of 3. Remember what we did? Factored that square root of 6 into square root of 2 and square root of 3, and the square root of 3 on the bottom can be divided out 4 times the square root of 2. So it's just like if you went back to the original, you might notice that in the radicals, you can divide out the same number. As long as they're both radicals, you can simplify. So something like the square root of 12 divided by the square root of 2 ends up being both square roots. You can reduce them down. You get the square root of 6. And if you wanted to see that instead of crossing them out, I'll go this direction. Square root of 12 could be square root of 2 times square root of 6. I just factored it using the denominator, if possible. I'll divide those completely out until you do get the square root of 6. Then there's a process that's called rationalizing a denominator. Did I put that specifically on your notes? Rationalizing a denominator, maybe it's down below. Okay. What rationalizing a denominator will be, and we'll hit it again once it comes up in our lesson. But if we have something like 4 divided by the square root of 3, we do not leave square roots in the denominator. Because something like square root of 3 is a decimal that keeps going. You try and set up a division problem. 4 divided by, I think it's 1.7, blah, 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 something that goes on forever. There's no way you could really divide to see how many times it goes in. Because if this does never end, how can you figure out what to multiply it by to get 4? So instead of leaving the denominator in a square root of 3, we do what's called rationalizing it. We'll try and turn it into a whole number. So we will multiply by a certain square root, top and bottom, and the goal is to get the denominator to be a perfect square, so we can simplify it. So 3 times what is going to make a perfect square number? 3 times 12 would make 36. That's a perfect square number. If we go smaller, 3 times 3 would make 9. That's a perfect square. So either one of those could be used. So we're going to multiply by a certain fraction to turn the bottom into a number that can be simplified. So 4 times the square root of 3 over the square root of 9. What's the square root of 9? Square root of 9 is a 3. So when we get to rationalizing the denominator, we're going to end up with something like 4 times the square root of 3 over 3. The bottom has become a rational number instead of an irrational number that the square root of 3 was. So it's going to decimal. You don't believe that that's what it is?
I thought it was 30.
3 times 3 is 9, 12. Why am I saying?
What you said,
No, I didn't say it's a 3. I said square root of 12 is 2 times the square root of 3.
oh,
So if you got that in decimal to be like 3 point something, you need a little bit more, 3 point.
no, not 312. No, not that. 1 2. I got 3.46.
If you take 2 times the square root of 3, you might have to do square root of 3 and then times 2.
Yeah.
Same thing?
Yeah.
All right, so we'll do rationalizing denominator a little bit more once we get to that in the lesson, but that's a preview of what's going to be going on. All right, we're going to look at special right triangles today. Special because there are some right triangles that have 45 and 45 degree angles in them. In other words, if there's 2 angles congruent, there's going to be 2 sides congruent. That's an isosceles right triangle. It has a pattern as far as what the sides end up being. And one that has 30 degrees, 60 degrees, 90 degrees, there's a nice little convenient pattern for those sides. If we have right triangles that don't have those angles, we'll eventually get to the trig ratios of like sine, cosine, and tangent and use those instead of the nice patterns. But these two have a pattern that you can use easily. So let's lead up to the 45, 45, 90 triangle. It says a diagonal of a square divides it into 2 congruent isosceles right triangles. Since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 45 degrees. So another name for an isosceles right triangle would be a 45 degree, 90 degree triangle. It's one special type of right triangle. I'm going to have you explore a 45, 45, 90 triangle. So you've got some space on the paper there. Draw yourself a isosceles right triangle. One that would have 45 degrees, 45 degrees, 90. Isosceles right. Isosceles means two congruent sides. What sides would be the same length in a right triangle? The 2 legs, not and the hypotenuse. The hypotenuse is always longer. It's across from the 90 degree angle, so the hypotenuse is going to be longer. The others are across from a 45 degree angle, they're going to be smaller. So in your isosceles triangle, can you put in the measurements? Where's your 45 degree angle, 45 degree angle, and 90 degree angle? Okay, now pick a number that goes from the 2 up to 10. Don't go any bigger than 10. Pick a number. Put that as your leg length. Which leg?
Both.
It's actually both because they're congruent, right? Now do your Pythagorean theorem. and in simplified radical form, come up with what the hypotenuse is. Simplified radical form. Nothing. Write down If you didn't choose the same starting number, you're not going to have the same intermediate, obviously. Okay, so here, that goes out as a. All right, let's compare your side measurements. Nathan, what'd you start with for your sides? 4, 4, and what's your hypotenuse? 4 times the square root of 2 when you simplify. Anybody else do 4? Okay, another one. Riley, what'd you do?
I did 6.
Okay, 6 and 6 for her legs. Your hypotenuse.
I got kind of confused.
Got confused. Anyone else do 6? What'd you get for the hypotenuse? Okay, 6 times the square root of 2. I think you have a double 2 and a double 3 that would go out when you do your factoring. Okay. What do you do, John?
3s.
3. So 3, 3, and hypotenuse?
3 times the square root.
3 times the square root of
2.
2. Okay. Dalton, what measurement did you use? Use 4. Okay, that was the same as somebody else, right? Okay, got another length. You did 7. 7 and 7, and the hypotenuse ended up? Are you seeing a pattern? Okay, so if you use 12, and I know nobody should have, if I use 12 for the legs would be 12 and 12, the hypotenuse would be times the square root of 2. What if my leg lengths were square root of 3? Square root of 3, square root of 3. Square root of 3 times square root of 2? Should be square root of 6. Correct. Okay, there's a pattern for those sides, and that is our 45, 45, 90 theorem. And yes, I have it on the wall, but that's the pattern that results. Says in a 45 degree, 45 degree, 90 triangle, if you want to put isosceles right triangle, that's the kind of triangle you have to have in order to use this pattern. It's not true about any other right triangle, just this one. Both legs are congruent, and the length of the hypotenuse is the length of a leg times the square root of 2. Could you just do Pythagorean theorem to figure out the missing side? Sure, you could. But if you know this, you could shorten the work real quickly. Come up with what the hypotenuse is. So the leg is L in my notes there. The hypotenuse would be L times the square root of 2. When you get to your trig class after Algebra 2, a lot of you will be taking trig. The first day or so, she'll run back through right triangle, 30, 60, 90s, 45, 45, 90s. So if you would have the coefficients of this pattern memorized, it'll give you a step to remembering that in your trig class. So what would be the numbers to memorize? Well, the coefficients, L and L, that would be like 1L, and square root of 2 times L. So if you learn with a 45, 45, 90 that it's 1, 1, and the square root of 2, that will be something you'll need to use over and over and over in trigonometry. And I think the majority of you would be going to trig. All right, so if we know the if we know the leg, you're good at getting the hypotenuse. We'll do some going backwards also. Okay, let's go to some examples. Grab your marker board for me. Marker board, please. You don't have to take truth, but quite a few of you probably will. Okay. Kennedy, check what you're doing. Okay, this one, let's just do verbally. What's the value of x? 8 times the square root of 2. Okay. How about this one? I'll go a little bit harder. Okay, well, what are the two legs? 10 square root of 2 and 10 times the square root of 2. So then what do you multiply that by to get the hypotenuse? The pattern says you take whatever the leg is times the square root of 2 to get the hypotenuse. So you need to multiply 10 square roots of 2 times square root of 2. And we can simplify. Write that down and just simplify. You don't need to multiply them. You just need to take this one times square root of 2. It says that the hypotenuse is the length of the leg times the square root of 2. So this is the leg, multiplied by the square root of 2. 10 times the square root of 10 times 2. Okay, show me what you came up with. Okay, show me again. Okay, the square root of 2 you have on there? No. Okay, let's show some work here. We're a little bit stuck. Okay, the hypotenuse is 10 times the square root of 2. I know that's a weird leg, but that is the leg measurement, 10 times the square root of 2. We have to take the leg times the square root of 2 because that was our pattern. We did integer leg measurements. Legs are not always integers. So this one is just an example of a different type of measurement. So 10 times the square root of 2 is the leg, multiplied by another square root of 2. That's going to be 10 times the square root of 4. What's the square root of 4? Just a plain old 2. Not a square root of 2, it's just a plain old 2. So this is like 10 times plain old 2, which is 20. All right, let's try another one. That's kind of small, but it says 5 times the square root of 3. Yep. Makes up some different numbers in there. So to get the hypotenuse, which is what you're looking for, take that leg times square root of 2.
I'm not gonna wait that far down.
Yeah, you can multiply those square roots together.
I didn't do my good.
Okay, let's see. Got them backwards.
Oh, sorry, Brenda.
5 times the square root
Sorry,
of
not as
6.
good as you.
Okay, that one should simply be 5 times the square root of 6. That one, if you do the factoring tree, there's nothing that you can do to simplify it. the hypotenuse. So you're not gonna multiply by a square root of 2, you wanna go backwards. So you need to take 15 square roots of 2 and divide by the square root of 2.
Almost cancels, just 15.
Yeah. So the square root of 2's will just cancel out, divide out. So you should be getting just 15. 15, 15, 15 times the square root of 2 was the hypotenuse. Okay, how about if the hypotenuse is just 5? Not 5 times the square root of 2, but just 5. To get the leg, you have to divide by the square root of 2. Not done. So how do we get 5 divided by the square root of 2? Simplify. Okay, this is where we'll have to come over to this rationalizing denominator idea. So with the square root of 2 in the denominator, what you should multiply by top and bottom is square root of 2. So take the 5 square roots of 2, multiply by square root of 2 on top and bottom. Denominators isn't right, yeah. Okay, all right, let me finish here. 5 times the square root of 2 over, some of you are showing me 4, it's the square root of 4, which is just a plain old 2. So we get 5 times the square root of 2 over 2. 5 times the square root of 2 over 2 is the length of the leg. Right, that one makes sense when you see it? Sounds like? Yep, we will do some more. Okay, let's do just a little more rationalizing. I think at the bottom of your notes or that area, I gave you these 2 problems. To rationalize the denominator, we're going to multiply by a fraction. That fraction is going to equal 1. I'm just doing those 2 practice ones at the bottom of the answer. Let's rationalize the denominator on each one. So what would you multiply 5 over the square root of 3 by in order to rationalize the denominator?
Square root of 3.
Square root of 3, top and bottom. So multiply by square root of 3 on the top and bottom. Why is that the better choice? Because of what the denominator does. Okay, we get 5 times the square root of 3 over the square root of 9. Square root of 9 is plain old 3. So on the top we get 5 times the square root of 3, but on the bottom we have just 3. You know those tests that you have to take lots of times, those standardized type of tests? If you calculate and you think you're looking for the answer 5 over the square root of 3, they're not going to give you that answer because that's not a proper form. They're going to have the 5 square roots of 3 over 3. So unless you know how to get from what you have to the answer that they're showing, you might get stuck. Okay, let's try the second one. 8 over the square root of 2. What are you going to multiply that one by to rationalize the denominator? Square root of 2, top and bottom. Simplify a little more, Tina. So multiply by the square root of 2, top and bottom. I hope you're doing these on your notes. 8 square root of 2, 8 times the square root of 2 over the square root of 4. And the square root of 4 is plain old 2. Now this one has a little bit of simplifying before we finish. You cannot simplify the square root of 2 and the plain 2, but you can simplify the plain 8 and the plain 2. So 8 and 2 can be divided by 2. So in the end, we get 4 times the square root of 2 as our measure. Thumbs up or down if those examples seem to make sense. Okay, those that are showing me are saying yes. How do you get which part? Yeah, just simplified the 8 and the 2. All right, so we'll watch for rationalizing the denominator to make sure that we get it simplified correctly. Okay, probably one more that you have to rationalize on, so each of you work this, and let's see where you end up with. The hypotenuse is 16. So what's the leg length? In simple radical form. This kind of a triangle, you're either multiplying by the square root of 2 or dividing by the square root of 2. And which side you have and which one you're finding. Just reduce your 16 and 2. What's the square root of 4? Not square root of 2. Okay. No, when you reduce 16 and 2, isn't that going to be an 8?
Oh,
Okay, so that last one ended up 8 times the square root of 2. Okay, so if you need to, on your notes on that triangle, that theorem, write, that side times square root of 2 equals hypotenuse. Hypotenuse divided by square root of 2 equals side. So that's what you're doing, either multiplying or dividing by square root of 2. Now if we just put that in a story problem, Jan is cutting a square of material for a tablecloth. The table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches. So it will hang over the edges of the table. So what's she really want the diagonal to be? 46. What size of square should Janet cut to make the tablecloth? Round to the nearest inch. So draw yourself a square tablecloth. Square. What's special about a square? All sides are the same length. And the angles are? 90. That could end up being a 45, 45. The diagonal is 46. You're supposed to come up with how long the sides should be. To the nearest inch. When you round it by the ways. 46. We want it to have an extra 10 inches. On the diagonal so that it- If this is saying round to the nearest inch, do you have to rationalize the denominator? No. You can just take the number divided by what you need to and come up with what the decimal. I think that would be the answer. Can you give me a decimal answer, like it's asking for? How'd you get a decimal? Probably just take 46 divided by square root of 2 equals.
2.9.
To the nearest inch,
Yeah, I think it's
would round up to 33. I do like what you were showing me. It does come out to be, 23 times the square root of 2 when you simplify. But the directions said round to the nearest inch. So a lot of you were giving me that it was 23 times the square root of 2. Yes. But that rounds to be 33 inches.
Oh, an extra 10 inches, that's,
Isn't that 32.5? Got a calculator? Take 23 times the square root of 2. Comes out like 32.5. Okay. All right, so read the directions to see if decimal or radical. Lots of times those will ask for a radical answer because of the pattern. Okay, let's explore the other one. To create a 30, 60, 90 triangle, let's start thinking about an equilateral triangle. So on your note paper, make yourself a 30, 60, 90 triangle by starting with an equilateral triangle. So draw yourself an equilateral triangle, kind of large, so you can see some numbers in there. Make it look like all sides are the same length and all angles would be, how many degrees? 60. Make all those angles the same. 60, 60, 60. And I'm trying to make all sides the same length. Okay, how do we turn that into a 30, 60, 90 triangle? Okay, put an angle bisector or an altitude. I'm going to go from just the top point. If I cut that exactly in half at a right angle, that's going to make a 30 degree, 90, 60. Notice each half is a 30, 60, 90 triangle. So we've created two 30, 60, 90 triangles. Okay, to make this not real difficult, pick an even number from, let's see, either 4, 6, 8, or 10. Pick one of those even numbers. And put that as your side length. Well, all of them would be the same, right? Of the equilateral triangle, whatever side. Now go from there and find what the sides of the 30, 60, 90 triangle are. Making use of Pythagorean theorem as needed. We're going to try and come up with what you're looking at. Some of you are peeking at the wall of your notes. We're going to try and support that. On that other leg, do the Pythagorean theorem correctly. It's not a 45, 45, 90, so you can't use that pattern we were just doing. Back to the Pythagorean theorem to find your other leg. That's the height. I'm coming up with two pairs. Anyone do my triangle? I'm coming up with my height to be 4 times the square root of 3. Okay, so who started with a 4 on the outside? Okay, you got 4, 2, and your height was 2 times the square root of 3. Anyone start with 6 on the outside? Okay, 6, this was a 3. What's your height? Square root of 27, when she factors a 3 and a 9, 9 is 3 and 3. Sounds like you'll have a pair of 3's that goes out, and then an extra 3. So how about 3 times the square root of 3? Did anyone use 10? Okay, Riley? 10, 5, and...
I didn't get it all the way through.
Okay, what are you trying to simplify? Trying to simplify square root of 75? Is that the right number? Okay, so 5 times the square root of 3 is what it ends up being. Are you seeing a pattern as far as the sides? If you started with the hypotenuse, what's this short leg? How is that related to the hypotenuse? It's half of what the hypotenuse was. And then your height is that number, that half, times the square root of 3. So it's easiest if I say, let's start with the 4 as far as the pattern. Okay? A lot of you are looking at the wall to see, what is it, what is it, what is it? Okay. It goes like this. we used the variable on the short leg. Yep. And it's at the end, kind of the end of the board up above there. It's turned differently than my notes right here. But the shortest leg is what we typically put the variable on. How do you know which leg's the shortest? It's across from the smallest angle, which would be 30. So across from a 30-degree angle, this is what we're going to call the short leg. If you know that one, then you can multiply to find the others. The hypotenuse is always twice as big. That's why you started with the hypotenuse and divided by 2 and what you just did. I'm just kind of reversing it, saying if I start with the short one, take it times 2 to get the hypotenuse. The longer leg is the short leg's measurement times the square root of 3. By doing the Pythagorean theorem, you would always end up with that when you simplify it. So let's start with the short leg sometimes, the hypotenuse sometimes, and then hit the harder one where you start with the longer leg. So you're either multiplying or dividing by 2 or by square root of 3. Depends which side you're looking for. And by the way, what number's bigger, 2 or the square root of 3? 2. So 2 times something's going to give you the longest measurement. That's always the hypotenuse. So don't think that square root of 3, because you see a 3 there. Square root of 3 is not bigger than 2. It's actually smaller. Okay, so let's start with the hypotenuse. This is kind of like what you were just doing. So if you have the hypotenuse, to get smaller, you're going to divide by what to get the short leg. The pattern with the hypotenuse. Hypotenuse is side multiplied by 2. So if you want to put like AC, if you want to put that is hypotenuse. That would help you make sense. Okay, so hypotenuse divided by 2 gives you, is that x or y? Which one's the short leg? X. So x is 11. We divided the hypotenuse by 2. Okay, and then the long leg is the short leg, which we now have 11 times the square root of 3. That's it. Only on a triangle with the angles of 30 degrees, 60 degrees, 90 degrees. Okay, let's start with a different side. Let's start with the longer leg. What's the pattern on the longer leg? The short one times square root of 3. So to get x, we have to take 15 and divide by square root of 3. An alarm go off in your head, can't leave a square root in the denominator. Rationalize that. Multiply by square root of 3, top and bottom. Getting the 15 and the 3 to cancel. So we get down to 5 times the square root of 3. I need to show work on that step. Okay, so then that's the short leg. To get y, to get the hypotenuse, what do we multiply the short leg by? 2. So what's 5 square root of 3 times 2? 10 times the square root of 3. Because you're not multiplying by another square root, the square root doesn't change. So we got 5 square roots of 3 and 10 square roots. Who's lost? back around. Okay, which side did I start you with? Hypotenuse is what I started you with. Okay, so look for what's the pattern for the hypotenuse. It's 2 times the short leg. Which is the short leg, x or y? X. So you could put 18 times the square root of 3 equals x times the square root of, or times 2, sorry. You could put 18 square roots of 3 equals x times 2. So what's 18 square roots of 3 divided by 2? Simplify. Divide each side by 2. So 18 square roots of 3 divided by 2. X will become 9 times the square root of 3. All right, now the long leg. What's the pattern for the long leg? Right, we have to multiply this short leg times the square root of 3. So we need to take 9 square roots of 3 times the square root of 3. Oops, showed the final answer there. So 9 times the square root of 9. And the square root of 9 is a plain all 3. So that's like 9 times 3, which is 27. So our sides were 9 times the square root of 3 and 27. If you get one of them figured out, then you could do Pythagorean theorem to find the other. But if you learn the pattern, all will be fastest. Anyone still need the screen? Okay, so I'm going to back off and have you do it. What are the 2 sides? Figure out if you're starting with the hypotenuse, the short leg, or the long leg. Give me the other side. This pattern works on what kind of triangle? Just one that has 30 degrees, 60 degrees, and 90 degrees. The hypotenuse, you take the short leg times 2. Should be long. No, that's this big. Okay, answers here. The hypotenuse was y. That's 5 times 2. Y was 10. X, the longer leg, should have been 5 times square root of 3. How did I get that? Well, to get the longer leg, you just take the shorter one times the square root of 3. This was the short leg. So just 5 times the square root of 3. Hypotenuse is the shorter leg times 2. So 5 times 2. 10. Think about your equilateral triangle. That relationship was that if you start with the hypotenuse, short leg's half as much. And this ended up being that short leg times the square root of 3. Okay, how about this one? Start you with the hypotenuse. And instead of finding the hypotenuse, you're going backwards. So instead of multiplying to find it, you're gonna divide to find a different side. And then find what y is after you find x. What's the pattern for the hypotenuse? Got your notes here? I'll look at that triangle right at the end of the board there, just above it, see the S, the 2S, and S times square root of 3, that's the one we're using. The hypotenuse is 2 times the short leg. So any more marker boards to see? Some of you showed me them. Okay. Hypotenuse should have been, or excuse me, short leg should have been 12. So take the hypotenuse and just divide it by 2 to get the short leg. And then take the short leg times square root of 3 to get the longer leg. So it should have been 12, and 12 times the square root of 3? Yes.
Will it be up to test?
They will. They'll be up for a chapter or 2, and then I'm going to take them down so that we will still use them, but I need you to memorize them. But yes, it'll still be up there. So you'll need to be able to tell, do I multiply or do I divide? Okay, one more sample. One more sample, starting with the longer leg. What's the pattern on the longer leg? Go backwards instead of multiplying by what the pattern has, we'll divide by what the pattern has for that side. We have to find y before we can find x in this one. Okay, the 9 is the long leg, right? Long leg has the pattern of being the short leg, which is y in this problem, times the square root of 3. So to get y, you have to take 9 and divide by the square root of 3. Cannot leave it as 9 divided by the square root of 3. And it didn't say I can do decimal. So I'm rationalizing to get a nice denominator. And it reduces 3 times the square root of 3 was y. Now to get the hypotenuse, which is x, you have to take the short leg, which we just found, times 2. I don't remember if the boards I saw had that right. I don't know if I said yes on some board that was not right. Okay, the short leg times the square root of 3. Or times 2, I mean. gonna show the complete solution there. Okay, oh, we better hustle. Okay, the problems for today are page 1, or page 360. So don't leave me before you write it down. Or did it? Okay, we're on page 360. Numbers 1 through 7, 9 through 15, 30, 32, 30. A little bit of review. Just 7. Okay. And reminder, work on your cumulative test some more. Get a little bit more done each day, 10, 15 problems. All right.
Oh, easy there. I'm trying to walk
We
here.
made it.